Hello everyone, welcome to today's webinar on Mastering Kubernetes Monitoring and Cloud Costing. I am Shreyas. I work as Senior Engineering Manager for SixthSense Observability. It's my pleasure to guide you through this webinar as we explore the intricacies of Kubernetes monitoring and cloud costing. Throughout this webinar, we will be delving into valuable insights and best practices to help you master Kubernetes monitoring and optimize cloud costing within your organization. Whether you are a seasoned professional or new to these concepts, I'm confident that you will find this webinar both informative and engaging. So without further ado, let's embark on this journey together and unlock the secrets to mastering Kubernetes monitoring and cloud costing. Over the webinar session, we will go through what is Kubernetes, what are the benefits of using Kubernetes, why it's a challenge to monitor Kubernetes, and what is our strategy to monitor Kubernetes, and how do we optimize cloud costing. Kubernetes is an orchestration tool. It's a powerful tool for managing containerized applications in a highly efficient and scalable manner. With Kubernetes, developers can package their applications into containers, which encapsulates everything needed to run the software. If you think of a traditional system, the VMs, which has everything, you deploy your applications on VMs. So each container is like a small VM, and these containers can be distributed across cluster of machines, handling tasks such as deployment, scaling, and management automatically. Why do we need Kubernetes? What are the benefits of Kubernetes? Kubernetes, as I mentioned, it's an orchestration tool, and it is highly portable across all cloud vendors. Maybe it is on-prem, hybrid, public cloud, it works the same. And it integrates with any of these mentioned clouds with ease. Where can we use Kubernetes, right? What are the use cases for Kubernetes? Lift and shift, facilitating the moving of on-prem apps to the cloud. So when there is a digitization happening in your organization, and when you want to increase the scale, increase the availability of your system, you want to move your applications from traditional systems to new age microservices, which will be residing either on cloud, on-prem, and Kubernetes takes care of it pretty easily. It is one of the best tools available to deploy your microservices applications. Heavy computing. In traditional systems, in like VMs, there is a set CPU memory available for you. But in Kubernetes, you can set your minimum and the maximum usage you want as you scale. So there is no limit to use what CPU and memory. It can be pre-configured as a minimum and maximum. It can go as high as your cluster CPU and memory. Microservices. In today's world, wherever we go, we hear microservices. And Kubernetes is the best option to deploy the microservices because of its ease of deployment, because of its ease of managing network, and ease of deploying an application into Kubernetes. With the traditional system, it needs a lot of expertise to get your simple app running on VM. You need to use web servers, you need to use different things. With Kubernetes, it's fairly simple. And with machine learning being the talk of the town, managing machine learning workflows to deploy faster AI-based applications is much easier in Kubernetes. CI/CDs, there are well-known lot of CI/CD tools which is available, can be integrated very easily with Kubernetes. What are the features of Kubernetes? So we heard the benefits, and then now we understand what are the features of Kubernetes. Automated deployment, as I mentioned, the integration with CI/CD is pretty easy. So automated deployment, it's a one-click deployment you can achieve through Kubernetes and the CI/CD integration. Container orchestration, load balancing, service discovery, auto scaling. You can do HPS, which is horizontal pod scaling, easily through a YAML files. You just need to mention how many replicas you want, what is the minimum replicas, till what replicas we can grow based on your CPU and memory usage. For example, if your CPU goes above 70% and you want to scale up one more pod, it is automatically handled within Kubernetes. Storage orchestration, you can volume mount your storage to the stateful sets. All these can be handled through deployment in Kubernetes. Secret and config management. So all your secrets can be managed using kube secrets. So it will be secured within the cluster. Rolling updates and rollbacks. Rolling updates and rollbacks is very important when you move from one release to another release. You don't need to have a downtime when you have a release. You just need to configure it for rolling updates. So when you go with the new release, just the old pods automatically get updated with the new images. Once it gets updated, then the pod comes up and the older pods goes down. So there is no downtime. So rolling updates helps you attain high availability as well. Portability. So as I mentioned in the previous slide, Kubernetes can be portable across any kind of cloud. Today you are running on GCP, tomorrow you want to go with AWS or the Azure, or you want to use the hybrid cloud. Your deployment files, everything remains same. So its ease of portable across clouds is what makes it efficient. Scalability, as I mentioned, using HPS you can scale your pods, you can auto scale your nodes as and when you want it. Self-healing, you can set up your health checkpoints. When the health checkpoint is not active, Kubernetes automatically restarts your pods. And using Kubernetes on top of Istio, you can secure your networks. You can set policies, who can access what is your ingress policy, what is egress policy, all that you can manage using just Kubernetes. So let's understand the adoption of Kubernetes. So year on year, there is a growth of 20 to 23% in adoption. In the enterprise companies, almost 61% of the organizations have already adopted Kubernetes. 22% of them planning to adopt Kubernetes in this year, and 9% of the companies are still thinking about this. But as you see here, the adoption is already above 60%. So with the high adoption, I'll come to the challenges. Kubernetes, it is very important to understand the Kubernetes and its use cases and how we can monitor Kubernetes. And as we mentioned the use cases, benefits and adoption, let's understand why monitor Kubernetes. What are the challenges involved in monitoring Kubernetes? As I'm saying here, Kubernetes solves problems like a boss, but also create new ones like a mischievous genie. What does it mean? Kubernetes solves a lot of traditional issues, but along with it, it also comes up with new problems. Why do we monitor Kubernetes? What are its challenges? Kubernetes is complex. In the previous slides, while I was mentioning benefits, adoption, what I also need to bring up is what are the challenges of monitoring Kubernetes, or what are the challenges in adopting Kubernetes. It is complex. It needs a skilled DevOps to manage Kubernetes. Kubernetes is, as I mentioned, is a powerful container orchestration platform. However, its complexity stems from its robust feature set and the multitude of components involved in creating and managing the Kubernetes clusters. Setting up and configuring Kubernetes clusters requires a deep understanding of its architecture, including components like pods, services, deployments, stateful sets, config maps, and etc. Managing resources, networking, storage, security, and other aspects within Kubernetes adds to its complexity, especially for organizations with limited experience or resources in cloud-native technologies. If you don't have the skill set and if you're not monitoring Kubernetes well, it will become a bottleneck for you. And in Kubernetes, everything is ephemeral. When I say ephemeral, what is it? In Kubernetes, all workloads are designed to be ephemeral, meaning they can be easily started, stopped, replaced without impacting the overall system. That's the beauty of the Kubernetes, but that's also a challenge. Pods, which are the smallest deployable units in Kubernetes, are ephemeral by nature. They can be scheduled and rescheduled on different nodes within cluster based on resource availability and scheduling. While this ephemeral nature enables agility and scalability, it also introduces challenges. related to state management, data persistence, application resiliency, especially for stateful workloads. And another major thing to consider here is the cascading failures. Kubernetes operates in a distributed interconnected environment where components and services rely on each other to function properly. A failure in one part of the system can lead to cascading failures, which downstream services are affected, causing a ripple effect throughout the cluster basically. So if your cluster has a problem, your node has a problem. If your node has a problem, your deployment has a problem. If deployment has a problem, your pods has a problem. So if your pods has a problem, then your application will not function as expected. So there are major issues for cascading problems: network issues, resource constraints, misconfiguration, and many software bugs as well. Kubernetes also generates a vast amount of monitoring and metrics data compared to traditional VMs, what we used to have, or like a bare metals. So for example, one VM or a bare metal will have one set of CDM metrics. But with Kubernetes, there are metrics related to containers, pods, nodes, clusters, networking, storage, and many, many more. Because of this extensive set of metrics provided, to provide deep insights of the health also, performance and resource utilization of Kubernetes infrastructure. However, managing and analyzing this large volume of metrics can be challenging. May require sophisticated monitoring and observability tools to extract actionable insights effectively. And another problem with having so many metrics is if you're not having a proper observability policy, you will have a lot of alert fatigue. When I say alert fatigue, it means if you set up an alert for each individual metrics, then if there is any small thing goes wrong, you will have hundreds of alerts in your mailbox or in a Slack channel, and you don't know which one to take seriously and which one not to. And if not for the effective observability, without proper correlation, analyzing or finding an RCA become a very manual and tedious task. So DevOps becomes overworked if you get such alert fatigue. So many of them may not be even actionable or very low priority. We don't even need to work on them at this point of time. But because you don't have the correlated information, you don't have the RCA, automatic RCA, your manual RCA, it takes a lot of time and takes a lot of effort from your team as well. So to mitigate alert fatigues, organization need to implement effective alerting strategies, including setting appropriate thresholds, prioritizing alerts, implementing automation, continuously refining alert rules based on feedback analysis, which is a very time-consuming effort, and also it needs a lot of people to manage it. So in the traditional system, we all were used to reactive monitoring. So, but with Kubernetes, reactive monitoring is something which you cannot afford to do. Why? I'll tell you. So when I say Kubernetes, as I mentioned, there are 10,000s of metrics, massive amounts of alerts. How to identify and isolate the problem, correlate metrics. Is your container causing a problem? Host, neighbor, cluster, which dependencies on downstream systems is having a problem. It will become really tedious to manage all this with manual RCA and reactive monitoring. So how do we manage this? How do we monitor Kubernetes effectively? That's where we're going to explain what is our strategy. So as I mentioned, the challenges in Kubernetes while adoption, and how you need a lot of people to manage Kubernetes efficiently, and also having high availability without any cascading problems. So how do we solve it? What is Rakuten SixthSense strategy to solve this problem? At the heart of this SixthSense monitoring strategy includes several components. Mainly, it includes metric collection, metric aggregation, correlation, auto baselining, forecasting, and correlated alerts, and root cause analysis in your alerts. So, what is metric collection? So, metric collection forms the foundation of our monitoring strategy. By gathering a comprehensive array of metrics from various sources within our infrastructure and applications, we gain valuable insights into health, performance, and behavior of our systems. These metrics serve as our eyes and ears, providing us a real-time visibility into every facet of our operation. But collecting metrics, is it enough? But it's not. It's just the beginning. The true power in our ability to aggregate and consolidate these metrics into meaningful data sets that offer a holistic view of your environment. Through meticulous aggregation, we gain a unified perspective that enables us to identify trends, patterns, anomalies across your entire core system. Kubernetes not only refers to your infrastructure, your underlying applications is also running on Kubernetes. So we have to correlate your application with Kubernetes. So if your pod goes down, that means your application is also down. These are the kind of correlation which we, through the data sets what we have, we establish these correlations. In a complex and interconnected environment like ours, isolated metrics can only tell part of the story. So that's why the correlation is very essential. By correlating metrics from different sources and systems, we uncover hidden relationship dependencies that might otherwise go unnoticed. What are the downstream systems getting affected? This deeper understanding allows us to identify the root causes of issues and proactively address them before they escalate. And also, we do something called as auto baseline. To further or enhance our proactive approach, we employ auto baselining techniques to establish normal operating parameters of our system. By continuously analyzing the historical data and trends, we can dynamically adjust our baselining threshold to adapt to changing conditions. So, with auto baselining, you don't have to set up alerts at each and every metrics. Our auto baselining system can adapt and raise an anomaly or an alert based on the threshold. So, along with auto baselining correlation, we have something called forecasting. With forecasting, we also look at the future with forecasting capabilities. By analyzing historical data and trends, we can predict future patterns and anticipate potential issues before they arise. So that is why we call it as a proactive approach. In reactive approach, you'll get to know after it happened, but in proactive, we can predict future to certain limit with the historical data set what we have. This foresight empowers us to take preemptive action, mitigate risk, ensuring smooth operation and uninterrupted service delivery. So in current world, we all know that having 4 nines of availability is not good enough. We all want to achieve 6 nines, 7 nines. So for that, forecasting plays a major role. If you identify an issue well in advance, you can mitigate without having your system going down. And we have something called correlated alerts. So when anomalies are detected, right, our monitoring strategy doesn't just stop at raising individual alerts. Instead, we correlate that alerts to provide more comprehensive picture of the underlying issue. So for example, if you have 2 alerts, like one is CPU and one is response time. So when CPU increases at a certain threshold and your applications become slow, and that's when you get the response time alert. Our system can identify correlated information that, okay, because of your CPU is gone high, your response time is also gone high, and that is why you are getting an alert. By having this correlated information in the alerts, you can easily identify where is the problem. We would not say it is 100% efficient, but it will be your first go to look at the root cause. So alerts is not just raising an alert telling you there is a problem, we also tell you where could be the problem. And finally, we give you probable root cause analysis as well. With the correlated information what we have in our system with historical data, our monitoring strategy facilitates rapid and effective root cause analysis. By embedding RCA capabilities directly into our alerting system, we can quickly drill down to the underlying cause of an issue and take targeted remedial action. This proactive approach not only accelerates incident resolution but also helps prevent reoccurrences as well. So, in conclusion, right, for Kubernetes, the SixthSense monitoring strategy is not just a tool or process, it's like a mindset. It's a mindset that prioritizes visibility, proactive action, and continuous improvement. By embracing this mindset and leveraging the powerful capabilities of our monitoring strategy, we can navigate the complexities of your environment with confidence, ensuring the reliability, resilience, and performance of a system. So, with the above mentioned strategies, we are 100% sure that we can help you monitor your Kubernetes infrastructure efficiently, reducing your workforce to monitor Kubernetes, and at the same time having high reliability, resiliency, and performance of your systems as well. So let's understand before we go to the cloud costing, let's understand what are the key metrics which we monitor. So the key metrics, as I mentioned, there are thousands of metrics. We collect all these metrics, we do aggregations, and then we identify which are the important metrics to monitor and what is the correlated information between these matrices, along with logs, traces. We collect logs, we collect traces, we collect infrastructure metrics. We correlate all that information. We give you context when alert happens, and at the same time probable RCA as well. Okay, so till now we looked at what is Kubernetes monitoring, why do we need it, what are the challenges for adopting Kubernetes. Now another elephant in the room, which is cloud cost management, right? So with public cloud, with Kubernetes, it is easy to deploy an application and make it run. It is much faster. It is like 50x faster to the traditional system. But as I mentioned with Kubernetes, it solves the old problems, but it comes with the new challenges. Similar to that, we have public clouds where it is easy for our application to be deployed, keep it secure, manage it, but along with it, what comes is the cost. So end of the day, if your business is losing money on cloud costing, what is the use of keeping everything efficient? We're not making any money out of it. So how do we handle cloud cost optimization? How do we keep our cloud costing below the current usage, or how do we keep it more efficient? So as I mentioned, cloud computing has become an indispensable tool for businesses, offering unparalleled scalability, right, flexibility, and efficiency. However, with great power comes with great responsibility, and effective management of cloud costs is essential to ensure optimal utilization of our resources, maximizing return on investment. If you don't have a return on investment, why do we even invest, right? We all invest, but if we don't have a return, why do we even bother investing? So let's start first with the numbers. As per the industry standards, the enterprise level cloud usage is from 1 million to 2 million per year. That is from minimal is what I'm talking about. And for that 1 to 2 million, efficiently used infrastructure in the cloud is only 72%. So extra 28 to 30%, we are paying more. So why are we paying more? Because there are a lot of services we don't even use 24/7. It is idle and over usage of resources. When you need 2 CPU, we are using 4 CPUs. When you don't need 16 GB of RAM because it is available, we are using 16 GB of RAM. All this is adding to your cloud billing, and you don't need 30 days of your logs in cloud. You can only have 7 days. That too, for lower environments, you can only keep for 7 days. There are multiple strategies how you optimize your cloud cost. But basic idea is most of the enterprises are spending 30% more than they should actually spend on the cloud. So how we can help in optimizing your cloud cost? So we, as in Rakuten SixthSense Observability, we are powered by our own in-house developed AI models. the transformers which we have built has input of seasonality. You can input a static parameters, and it can give you correlated information on multivariant analysis as well. So SixthSense, powered by our cutting-edge artificial intelligence capabilities, offers a comprehensive suite of tools and features designed to provide unparalleled visibility. So first thing, to optimize costing, you need to see where you're spending. So we give you that visibility and the benchmarking. So for example, if there is an event, for the last event, same capacity, you used 100 core, 200 GB of RAM, and that information is available today, and you input as a static parameter. Okay, we are repeating that particular event. For example, Christmas is happening again, and for this Christmas, you're expecting same traffic. What should be your infrastructure? With the historical data what we have and the usage data and the cloud billing, we can give you that information on benchmarking. What should you use? And we also can forecast. Okay, so now we are on 23rd, last 25th of December, you have used this much resources. With that, you definitely have to run your own performance test, but we will give you the inputs, like you can use this infrastructure to cater such requests. Or if you increase your traffic by 30%, current infrastructure, maybe you can increase it by 20%. That forecasting options will give you. And also with SixthSense Observability plus our AI ops, we have an integration with cloud billing APIs as well. So we have a usage information, we have a historical data, we know the trend, we know the benchmarking, we know the cloud billing. So based on this, we can give you forecasting as well, and also billing alert as well. Because of your usage, we can tell you you are underutilizing your cloud by 30% and you're paying more. With these alerts, you can easily, you have visibility, and these alerts, you can easily optimize your cloud with different strategies. Strategies to optimize cloud spending varies from corporates to corporates or enterprise to enterprise. But with this information, you can make the decision much easier. So basically, with SixthSense Observability plus AI Ops, visibility, benchmarking, forecasting, billing, all driven through AI, you can have a better estimation, you can have a better forecasting, and you can optimize your cloud spending. As I mentioned, 30% of the cloud usage is going unused. Imagine for every 1 million, you're adding extra 300K without using the resources. You can save that money. And we give you complete visibility and information about this billing through the integration of billing APIs as well. With that, I'm at the end of the webinar. If you have any questions, please feel free to ask me. Thank you.